Welcome back, everybody. We're diving into the heart of a thinking classroom today.
Okay.
Specifically, Chapter 10 of Building Thinking Classrooms in Mathematics.
Sounds good.
We are going to zero in on lesson consolidation. That crucial moment where we help our students move from, doing math to truly understanding it.
Right.
So imagine this.
Yeah.
Your students just totally aced a set of practice problems.
Okay.
But will they remember and apply those concepts tomorrow?
That's the question, isn't it?
That's the question.
Yeah.
And this chapter gives us the tools to make that happen.
Really interesting stuff.
I am excited.
Yeah, me too.
What's fascinating is that traditional consolidation methods, like just re-explaining or showcasing that perfect solution, often miss the mark.
They do. They really do. It's like handing someone a finished puzzle without showing them how the pieces fit together.
Interesting.
You know what I mean? They might see the end result,
Right.
but they haven't actively grappled with the process.
So we need to shift gears from presenting that polished final product
Yes.
to understanding the messy, beautiful process of learning, right?
Exactly. And that's where the idea of leveling to the bottom comes in.
Ooh, I like that. Leveling to the bottom. What does that mean?
It's not about dumbing things down or anything like that.
Yeah.
It's about recognizing that every student is on a different step of their learning journey.
Okay.
So by presenting a range of student solutions, starting with the least sophisticated and gradually building towards the most elegant, we create a roadmap for everyone.
So it's like creating a choose-your-own-adventure
Yes.
for learning math.
Exactly.
Each student can see where they are on that path and what steps they need to take to reach the next level.
And it makes the whole consolidation process way more inclusive.
Okay.
Students who are still grappling with the basics don't feel overwhelmed,
Right.
while those who are ready for more advanced concepts, they can still see how their thinking connects to the bigger picture.
So we've got all these different solutions, Raja.
Yes.
But showing them is just the first step.
Right.
How do we actually make students active participants in this whole consolidation process?
So that's where we move from showcasing to engaging.
Okay.
The chapter outlines 3 really powerful methods:
Okay.
whole class discussions, gallery walks,
Yeah.
and guided gallery walks.
Interesting.
Each one has its own strengths and potential pitfalls.
Gotcha.
Let's start with the most familiar one, whole class discussions.
I use those all the time, but I sometimes feel like they can easily become teacher-centered
Oh, yeah, for sure.
if I'm not careful.
Absolutely. That's a really valid concern.
Yeah.
The key is to make sure students are doing the heavy lifting
Right.
instead of just explaining the correct solution.
Yeah.
Try posing questions that encourage students to analyze different approaches, identify common errors,
Right.
and articulate their reasoning.
So instead of saying, this is how you solve it, we're asking, what do you notice about these different strategies?
Exactly. Now let's move on to gallery walks.
Okay.
This method gets students up and moving,
Yes.
which we know can boost engagement.
For sure.
They get to examine different solutions displayed around the room, sparking curiosity and peer-to-peer learning.
I've always loved gallery walks.
Me too.
There's something so energizing about students physically moving around and interacting with each other's work.
Absolutely. It taps into that natural curiosity
Yeah.
and allows for more organic conversations.
Right.
However, sometimes we need a little more structure.
Okay.
That's where the guided gallery walk comes in.
Guided gallery walk. Tell me more.
Okay, so it's essentially a gallery walk with a roadmap.
Gotcha.
The teacher carefully sequences the solutions that students visit,
Yeah.
creating a step-by-step journey towards deeper understanding.
So you're kind of curating a museum exhibit,
Yeah.
guiding students through specific thought processes and highlighting those key insights.
Precisely.
So it's about providing scaffolding
Yes.
without taking away that sense of discovery and exploration.
Exactly. This approach ensures students are exposed to key insights,
Okay.
and they develop a more cohesive understanding.
I like that.
But here's the thing.
Yeah.
All these methods,
Uh-huh.
they're meant to be refined over time.
Okay.
There's no one-size-fits-all approach.
Refining those methods.
Yeah.
What does that look like in practice?
Well, imagine this.
Okay.
You're facilitating a gallery walk.
Yeah.
You notice students clustering around certain solutions
Okay.
while others are being overlooked. So what adjustments could you make?
Right. What could we do?
Perhaps you could rearrange the order of the solutions,
Okay.
add prompts to guide their observations.
Interesting.
Or even have students vote on which solutions they found most intriguing.
So it's about being responsive to what's happening in the classroom.
Yeah.
Not just sticking rigidly to a plan.
Yeah.
Right.
Precisely. And the chapter highlights some fascinating research findings that can inform our refinement process.
Okay. Interesting.
Did you know that students are significantly more engaged in consolidation activities when they're standing up and moving around compared to when they're sitting down?
That makes sense.
It's pretty amazing, right?
Yeah. We talk about kinesthetic learning all the time.
Right.
But sometimes we forget to apply it to math.
Exactly. And it's such a simple change that can make a big difference.
For sure.
Another interesting finding.
There's more.
Limiting the amount of time spent on the most basic level of a task can actually increase overall engagement.
Really?
I know it seems counterintuitive.
Yeah, why would that be?
Well, think about it this way. When we dwell too long on that most basic level, we risk losing the momentum and the attention of students who are ready to move on.
Gotcha.
It's all about finding that sweet spot between providing enough time for understanding and keeping things moving forward.
I've definitely struggled with pacing during consolidation.
Yeah.
It's tough to strike that balance.
It is.
I like how the book emphasizes this point.
Yeah.
But those are just a couple of the research insights that the book has to offer.
Yeah.
What else can we learn from this chapter?
Well, the chapter delves into so many practical considerations.
Oh, yeah. Like what?
One that really resonated with me was the idea of not letting students erase their initial work.
Oh, absolutely. They see an error and immediately reach for that eraser like it's a magic wand.
But those so-called mistakes are like gold to us teachers.
Yeah, I was just thinking that.
They provide a window into the student's thought process, showing us where they might have gone astray, what misconceptions they might have.
I've noticed that sometimes the wrong answers can be the most illuminating ones.
Right.
They spark the richest discussions and lead to the biggest aha moments.
Exactly. So how do we encourage students to see the value in those initial attempts?
Yeah, how do we do that?
Even the messy ones.
Right.
Maybe we can frame it as like a detective story.
Ooh, I like that.
We're going to be math detectives today.
Okay.
And these initial solutions are our clues.
I love that analogy. It shifts the focus from being right or wrong to understanding the process of mathematical thinking.
Exactly. And speaking of practical challenges, the chapter also addresses a common teacher concern. What happens when you're doing a gallery walk?
Yeah.
And you encounter a student solution that's incomplete or just plain confusing?
I've definitely been there.
Yeah.
You want to showcase student work, but sometimes it needs a little help.
Yeah, totally. So what does the book suggest?
Yeah, what do we do?
It offers a couple of approaches.
Right.
One option is to ask the group responsible for that solution to clean it up a bit before the gallery walk.
Gotcha.
Give them a chance to add some explanations or clarify their thinking.
That makes sense. Gives them a sense of ownership over their work.
Exactly. The other option is to use that imperfect solution as a teaching moment.
During the gallery walk itself.
So how would we do that?
You could use a red marker to add notes or clarifications, prompting students to think about what's missing or how the thinking could be refined.
It's about using those imperfect solutions as springboards for deeper discussion, right?
Exactly. And of course, we can't forget about student sensitivities.
Oh, right, of course.
Publicly critiquing work can be a delicate dance.
It really can.
We want to foster a growth mindset without making students feel embarrassed or singled out.
That's such a crucial point, especially in math where students can be so quick to label themselves as good or bad at it.
Absolutely. The book emphasizes the importance of focusing on the task and the thinking process rather than on the student as an individual.
So how do we do that?
Instead of saying, you did this wrong, try saying, can someone help us understand the thinking behind this step? It's a subtle shift in language.
But it makes a big difference in creating a safe and supportive learning environment.
Absolutely. It's about framing feedback in a way that encourages reflection and growth.
Right.
Not shame or discouragement.
Exactly. Speaking of framing, the chapter mentions a potential pitfall that I've definitely fallen into.
Oh, what's that?
Taking pictures of student work and then presenting a slideshow.
Oh, yeah. I thought it would save time and make things more organized.
It's a tempting shortcut, but the book argues that it can actually be less effective than having students interact with the original work.
Why is that? I thought a slideshow would be more engaging, especially for visual learners.
Well, think about it. When students are passively watching a slideshow,
Okay.
they're not as actively engaged with the material.
Right.
But when they're physically moving around a gallery walk, examining the original solutions,
Okay.
they're more likely to notice details, make connections,
Yeah.
and have those spontaneous conversations that lead to deeper understanding.
It's about the tactile, hands-on experience, right? Like, there's a difference between looking at a picture of a painting in a book and standing in front of the actual canvas.
Exactly. And don't forget that sometimes those messy, scribbled-on solutions can spark more curiosity and discussion
Oh, yeah.
than a perfectly typed-up slideshow.
I can see that there's an authenticity to those original pieces of work.
Yeah.
Just can't be replicated. It's like seeing the artist's brush strokes, the evidence of their thought process.
Precisely. And that brings us back to the core message of this chapter.
Okay, what's that?
Consolidation is not just about reviewing answers. It's about building a thinking classroom.
I love that phrase, building a thinking classroom. What does that look like in practice?
It's about shifting our focus from getting the right answer to understanding the why behind the answer.
So go deeper.
Yeah. It's about encouraging students to analyze different approaches, articulate their reasoning, and justify their solutions.
So it's about creating a space
Yes.
where mathematical thinking is valued and celebrated,
Exactly.
not just the final product.
Exactly. And that's what makes consolidation so powerful.
Okay.
It's not just a tacked-on activity at the end of a lesson.
Right.
It's an integral part of creating a culture of thinking and inquiry.
All this talk about bottom-up consolidation and gallery walks has my teacher brain buzzing with questions.
Yeah.
But before we get to those, I'm curious about your personal experience with these ideas.
Okay.
Have you tried any of these methods in your own classroom?
Oh, absolutely. In fact, just last week, I was teaching my 6th grade class about finding the area of triangles.
Okay.
I had them work in groups to solve a few different problems. And then we did a gallery walk where they analyzed each other's solutions.
How'd it go? Did you use a guided gallery walk or let them explore more freely?
I opted for a guided approach because I wanted to make sure they were exposed to some key insights about base and height.
Okay.
And it was amazing. They were so engaged, asking each other questions.
Wow.
Really trying to understand the thinking behind each solution.
That's fantastic to hear. Sounds like a real thinking classroom moment.
It really was. And speaking of specific examples, the chapter also provides a bunch of tasks that teachers can use to implement these consolidation techniques across different grade levels.
That's awesome.
Yeah. The book breaks things down by grade band, making it super easy to find ideas.
Okay.
For example, at the elementary level, there's a task called Farmer John.
Okay.
It involves a farmer who has a certain number of chickens and pigs.
Good.
And the students need to figure out all the possible combinations.
I love that task. It's so simple, yet it can lead to such rich mathematical thinking.
Exactly. Imagine a group of first graders tackling this.
Right.
They might start by drawing pictures of chickens and pigs, carefully counting to make sure they have the right number of each animal.
Right. And then as they get older, they might start using more sophisticated strategies, right? Like maybe a table to organize their data, or even an equation to represent the relationship between chickens and pigs.
Precisely. And during consolidation, you could showcase those different solutions side by side, helping students see how their thinking can evolve over time.
It's like creating a visual representation of the learning progression.
Exactly. Now, moving up to the middle school level, there's a really intriguing task called Painted Cube.
Okay.
It involves dipping a cube into paint and then figuring out how many of the smaller cubes within the larger cube have paint on them.
I remember doing a similar activity when I was in middle school. That was one of those tasks that really stuck with me. I think it was the visual aspect that made it so engaging.
Absolutely. Some students might start by trying to visualize the cube in their minds. Others might draw diagrams or even build physical models. Using sugar cubes or something similar.
Right.
And then as they start exploring larger cubes, they might begin to notice patterns and develop formulas for calculating the number of painted cubes.
It's a great way to connect concrete experiences to abstract mathematical concepts.
Exactly. And finally, for the high school level, there's a challenging but fascinating task called 3D tic-tac-toe.
3D tic-tac-toe. That sounds like a fun twist on a classic game.
It is. Instead of playing on a flat board, you're playing on a 3-dimensional grid.
Wow. I can already see how that would add a whole new layer of complexity.
It does. And the task challenges students to think about all the possible winning combinations in this 3D space. It's a great way to introduce them to concepts like spatial reasoning, and combinatorial thinking.
These are just a few examples of the many tasks the book provides, but they really highlight the potential of using well-designed tasks to spark mathematical thinking and create those rich consolidation moments.
And remember, the goal is not just to complete the task,
Right.
but to use it as a springboard for deeper understanding and discussion.
So as we wrap up this deep dive into Chapter 10, what's the key message you want our listeners to take away? What's the one thing you hope they'll remember long after this episode is over?
I think it's this consolidation is not just about reviewing answers. It's about cultivating a thinking classroom where students are active participants in the learning process. It's about creating a space where they feel safe to take risks, make mistakes, and learn from each other.
Beautifully said. Yeah. It's about shifting our mindset from telling to facilitating.
Yeah.
From correcting to understanding.
Exactly.
And by embracing the strategies outlined in this chapter, we can empower our students to become not just proficient mathematicians, but confident, curious, and creative thinkers.
That's a beautiful thing.
Thank you so much for joining us on this deep dive into building thinking classrooms in mathematics. We hope you've gained some valuable insights and feel equipped to create those thinking classroom moments in your own practice.
My pleasure. Happy teaching, everyone.